Good morning, everyone. I'm Mohammed Nasser, and I'm here to make a physics tutorial for my project in physics. The basic concepts of force. Force is one of those words that get used both in everyday speech and in physics, but in this case, the technical meaning isn't all that far removed from the everyday meaning. When you think of forces in an everyday sense, you think of things that you do to try to change the behavior of objects or people. Pushing them, pulling them, hitting them, threatening them, etc. The basic idea carries over. Forces are things that change the motion of objects. To put a little more formally and give the broadest possible definition, here is it. Force is the quantification of an interaction between two objects. Oh, just wait a minute. If you have two objects that interact with one another in some way, you describe the size and effect of the interaction in terms of a force. Force, in turn, is related to the motion of the object via Newton's law of motion, of which there are three, because 3 is the magic number, and 3 is also my favorite number. An object at rest tends to remain at rest, and an object in motion tends to remain in motion in a straight line at constant speed, unless acted on by a force. The net force of an object is equal to the time rate of change of the momentum, or which is equal to mass times acceleration for reasonable sized objects at speeds much lower than the speed of light. If one object exerts a force on a second object, the second object exerts a force on the first that is equal in magnitude to the first force, and in the opposite direction. The 3 Newton's law. The first law of Newton is just the codification of common sense. Objects don't change their motion unless some interaction causes them to do so. If you see a change in the motion of some object, you can deduce that there must be an interaction to cause that change. And indeed, that's how we detected all the force we know about, which more later. First law of examples. One example is when a car is going and suddenly stops, the passenger will move forward. Another is when a pilot turns the plane and the passengers will want to stay the same direction, so it feels like they got pulled the opposite way. And the last one is also when a coffee mug gets left on the car and then the driver speeds away, the cup will want to stay at rest, so it will slide off the back of the car. Here are some examples of pictures of the Newton's law of motion. You see the marble that he stands on the horizontally, sliding down. The marble speeds up, rolling down the ramp. And when the marble tries to go up, the marble slows down, rolling up the ramp. And when the marble stands in a horizontally floor, the marble will neither slow down nor speed up, rolling on a perfect horizontally surface. The second law of Newton. The second law is just quantification of the first law. It tells you how big a force you need to get a given change in motion. The units of a force are defined in terms of the second law. A 1 Newton force is the result of an interaction that causes a 1 kilogram object to accelerate at 1 meter per second. Oh, I got only one example for Second's law. A horse is pulling a horse box, and this is the picture of a horse that pulling a horse box. And that's it. The another picture which a man smash or throw a golf ball. The same force exerted on a larger mass produces a correspondingly smaller acceleration. The third law of Newton. The third law tells you that interactions always go both ways. If particle A interacts with particle B, particle A is also affected by that interaction. This is why I specify that force is the interaction between two objects. There may be more than two objects in a system, 8 planets orbiting the Sun, say, but in terms of forces, you think about them 2 at a time. The interaction between the Earth and the Sun produces a force of the Earth and a force on the Sun. The interaction between the Earth and Jupiter produces a force on Jupiter and a second force on the Earth, and so on. You determine the motion by adding up the forces due to all possible pairs, and then applying the second law. The third law is just all about comparing objects to another object. That's the point of the third law of Newton. And so, if forces are interactions, what sort of interactions are allowed? Modern physics says that there are only 4 types of interactions possible between fundamental particles, though there's a sort of cottage industry in looking for a 5th. Every particle interaction you see is due to one of these 4 fundamental forces: gravity, electromagnetism, and the strong nuclear force, and the weak nuclear force. There are 3 third example of law. The third law. If you throw a heavy ball or block away from your body, the force exerted will push back on you, possibly pushing you backward onto the ground. You find it hard to walk on a slippery surface. This is the second one. Surface, because the only way you can walk forward is for your foot to push backward on the surface of the ground. Through friction, the ground is essentially pushing back against the force of your step. The third one. A rocket can be launched into space because the hot gases from it are being propelled downward from the rocket, causing the rocket to move upward with equal force. Gravity, of course, is opposing its acceleration during this reaction. This is the Newton's law of motion. The most obvious and inexplicable of the forces we see in daily life is gravity. The gravitational interaction says that all objects with mass experience a force that pulls them toward every other object with mass. The gravitational force is incredibly weak on the scale of fundamental forces, but is really obvious in everyday life because the mass of the Earth is gigantic, Every person reading this is being pulled toward the center of the Earth with a force that is rather substantial. 9.8 newtons per kilogram of your mass, assuming you're near the surface of the Earth. Anyway, if you're reading this from orbit, the force will be somewhat smaller. You're also attracted to the monitor of your computer with a force that's smaller by something like 10 orders of magnitude. By virtue of the fact that both of you and it are objects with mass, this force is totally insignificant compared to the other forces of you experience. But they're all the same. The next most obvious force is electromagnetism, which involves forces between charged particles. When your clothes stick to you on a dry winter day, that's electromagnetism. Odds are it's also holding some things to your refrigerator right now. But more than that, electromagnetism is responsible for ability to operate a computer. The atoms make up your body are held together by electromagnetism magnetic forces, as are the atoms making up the computer itself. Pretty much any everyday force you can think of other than gravity is ultimately due to electromagnetic forces between the component atoms of the interacting objects. The other two are less obvious but no less important. The strong nuclear force binds quarks together into protons and neutrons, and hold protons and neutrons together in the nuclei of atoms. It is, as the name implies, an extremely strong force, 137 times stronger than electromagnetism. The better than 30 orders of magnitude extra stronger than gravity. It also an extremely short range force. Protons and neutrons separated by more than 10 to the power negative 15, the radius of the nucleus of an atom, more or less, don't feel the strong force at all, so it's not something that you're likely to experience directly at any time soon. The final fundamental force is the weak nuclear force, which is somewhere between gravity and electromagnetism in strength. It's even less obvious than the strong nuclear force, and really only turns out indirectly through certain types of radioactive decay. Which is not to say that it's not important. The weak force plays a crucial role in determining the abundances of heavy elements, basically anything other than hydrogen. And since you're mostly made of heavy elements, that's pretty darn important, whether you realize it or not. But some way, I just gotta, post this one.